Okay, so quick video to show you how to solve for an unknown limit if you're given the area, especially when it's a function that we don't know how to integrate. But even if we do, this will be a lot easier. So re-looking at this question 1, where we've got this function and we're told that the area is equal to 24. So what I've done is I've actually put in the integral command in here. So just to show you, if I put in it again, so I'm in the graphing y equals. If I did math, go down to function integrate, press enter, I can put it into my graph, and then it will actually graph the integral for all values of x. All right, so if I just switch that one off. So what I've done for this question 1 is I've just put that in. Right, I've put in between 0 and x. Instead of the a, I've put in 0 and x, and there's the function. Look, just typed in as is. I'm not having to integrate this method. For y2, I've put in x equals 24. If we graph that, okay, this is what comes up. It took a bit of time to show, so I've already run that, but this is a graph of all the possible area values depending on what a could be. Okay, so we've got negative areas of positive. So if you remember, we ended up with 3 possible solutions anyway, so you can see we've got the 3. Now this one, the way we did it, if you remember, we went through this, look, all of this process, right? So we actually had to integrate it, we put it as 3, put it as equal to 24, but we then graphed this equal to 24 and solved it that way. So this method, what it can actually do is not bother with all that integration. Like I've said, I've just put that in, equals 24, but then the same process. This is the crossing. I know I want one. This negative value is not interesting to me. This one was going to be too big, so we just go for the calc intersect again, and then we've got first curve, enter, second curve, enter. The guess is put me to where I want to be, enter, and it'll come up with, eventually, x is 3, so that's the value for a. Same thing we got, so that was the solution. Now what's good about that, okay, is, like we were looking at this one, for instance, this one, I said we don't know how to integrate them. All right, we haven't got to that point, we might never need to, but what I can now do is if I go to my calculator, I'm going to put this one in, so y equals, I'm going to just switch this off, that off. So on my new one, I'm now going to put in same thing again. So bounded by the graph and the x-axis. X is between x is -3 and a, where a is greater than -3. So that means the lower bound must be the -3 and the upper bound must be greater than that. So let's put an x in there, right? And then I'm just going to put 2 to the power of -x, because I don't know how to do that as an integral. We haven't sorted it, so I'm just going to put that in d of x. Right. Then in y4, I'm going to put in the area that it needs to be. So it says the area is equal to 9. Right. So I'm going to put in 9 there. This time, graph it. It's going to take a while. Because it has to think, you see, it has to actually calculate all the integrals. There you go. So it's just slower because it's having to do each one has to be calculated. Taking its time. I'll pause and we'll come back to it. Okay, so I let it do its thing, and here we go. All right. Here is the integral graph of 2 to the negative x. I don't know what the function is for that. That's not a problem. It's there. The computer calculated all the values manually for it. This line represents the area equaling 9, and this value here, where it crosses, is the value of a. So the -3 should be here. So between this two, in this region here, that's the area we're talking about. Okay. Well, actually not, but we'll go through that in a minute. So I need to find that point. So second, calculate, intersect again. Right, first curve, second curve. There's only one intersection this time. Press enter. It's going to work it out. So I've got -0.8169, and that makes sense because it says give your answer to 4 significant figures. So -0.8169. Okay.